This video is really about logs and logarithms, so it's a bit of a revision lesson. And the reason why we're looking at that is because it's related to finding the distance to some of the most distant stars and galaxies. So we need to understand logs in logarithms in order to be able to solve these sorts of problems. So just to begin a reminder, so what we mean by a log or a logarithm, normally it's to the base 10. What it is the power to which 10 must be raised in order to get some other number. Now that might sound a little bit double Dutch, but let's have a look at what that means through an example. So the base 10 logarithm of 100 is 2. Why? Because 10 has to be raised to the power of 2 in order to get some other number, 100. So 10 to the power of 2 is 100. So that's what it's saying up here. It's the power to which the 10 must be raised in order to get this other number, 100. So we would say, this is how we would write it, log 100 is equal to 2. That's to the base 10. We won't worry about logs which are not to the base 10. 10 to the power of 2 is 100. So 2 is the log of 100. So the one which we say that is log 100 is equal to 2. Again, if we have a look at this example, we've got 10 to the power of 3 is equal to 1,000. 3 is the power to which 10 must be raised in order to get that other number. Log 10 to, log 1,000 to the base 10 is equal to 3. That number there. Again, 10,000, 10 to the power of 4 is log, now this should be 1,000, so that's a bit of a misprint there. I'll fix that up, won't I? With the wrong colour, doesn't matter. 10,000, the log of 10,000 is 4. It's this number here, it's the power that it has to be raised to. Let's have a look at this one. What would be the log of 150? Now if we have a look at what we've got, the logs that we've got so far up here, it's obviously more than 100, but it's not 1,000. So it's somewhere in between 2 and... So in instances like this, we'd call upon our calculator and find the log of that using the calculator. So to do that, first of all, we turn it on. And we're looking at the log of 150. So what we do is we go to here where it says log, and we type in 150, press equals, and that tells me there that 10 has to be raised to the power of 2.176 and so on and so forth in order to get 150. That's what we mean by the log of 150. Another example, (4,567). So we clear our calculator and press log first of all, then type in this number, and we say 4,567 and press equals. So we're going to get the log of that number, and that tells me that 10 raised to the power of 3.659 and so on and so forth is going to give me this number. Now, what if we know this number and we're after the actual number? Well, there we're looking at what we call antilogs. So we'll have a look at that. What we're asking now is, if the log of a number was 2, what would the actual number be? Well, you could probably tell me that that is going to be 100. It's 10 to the power of 2. 10 to the power of 2 is 100. What if the log of the number was minus 2? What would the number be? Well, it's going to be the reciprocal of this. It would be 1 over 100, and that decimal, of course, would be 0.01. Let's have a look at some other examples. Looking at the antilog of 1.4. Well, that's not something that we can use, we can work out in our head. So, again, what we can do is call upon our trusty calculator. Now this time, to work out the antilog of this number, what we need to do is first of all press the shift button. When we press the shift button, then we press the log and we type in this number. So that number then 1.4, and press enter, or press equals, we get 25.118 and so on and so forth. So that tells me that 10 raised to the power of 1.4 is this number. So this number is the antilog of 1.4. Now, what if the antilog is a negative number? In other words, we're dealing with 10 to the power of minus 1.4. So we clear our calculator, and again what we do is we type in shift log. So antilogs are shift log, and we type in minus 1.4 and then press enter, and so we get this decimal. You can see it's a small number there. It's 1 over 10 to the power of 1.4. It's the reciprocal of this. So it's a small decimal. So that will help you solve problems of this nature. These are the ones that we're looking at in our course, where we're given what's called the absolute magnitude of stars or galaxies. That's how really bright they are, and then the apparent magnitude and the distance. We'll be able to calculate the distance, and that distance will be given to us in parsecs. Now at this stage you may not know what absolute magnitude means, and I haven't explained that at all. I may not have explained apparent magnitude or parsecs. What this lesson is about is logs and how to find this number here when we meet up with that in problems. But the interesting side of this is, as I've said, we'll be able to use this to find the distance to the most distant stars and galaxies. Sounds like fun.